Hello, hello, hello. Just trying to configure, then we will start. Hello everyone. Today we are going to talk about asynchronous programming in C#, and in this seminar we will be covering from the starting with .NET 1.1 to the end, like 4.5.1. This is all about me. You can contact me with these things, and I have done a certification on programming in C# and web application development. I'm active on the blog, so you can follow me up. Today's agenda is first of all, to know what is asynchronous programming, and then what are the different options we get with the .NET framework on asynchronous programming. We have various ways to consume the asynchronous programming in .NET, and then we will look into the thread pool and asynchronous programming model. That is a way to handle asynchronous programming with the APM and EAP, and then finally we will be looking into the task. So these are the few things only. In this first part, I will be starting slowly with the history of it and then moving it to task. Most of the time we are ending with the task implementation currently. I hope everyone has used task. So what is asynchronous programming? Can anyone tell what is asynchronous programming? Right. Yeah, partially. Yeah, that is correct. The thing is, like, to give an example, if we go to the shop in general terms, if we go into shop and then we ask for certain items, let's say we have gone for purchasing pizza, and then we asked shopkeeper to give pizza with our requirements. So the thing is, we will just ask him, and then we will go somewhere else to have some other work, and then we will come back again after, let's say, 30 minutes to collect the pizza. So it's the same way. like the whole resource that machine will be having, that will go at the point where you are calling some long running task. So at that point, that thread will keep, thread will handle that stuff, and then the processor would be free to get more calls, means to accept more calls on that function or whatever functionalities you are developing. So the thing is, what asynchronous mean is, it's a Greek word, and that async means not with, and chronos means time. So not with time. And if you look into the pattern, so it depicts that only. Uh, if you look into the first synchronous version, we have sender over here, and then we will process the data and the receiver will get data. There's nothing there. But if you look into the asynchronous programming, we will start the process, this sender stop, and data will be processing the things, and then again if this thing is get processed, then this item will be getting called. So ultimately we will receive over here. So it's like intermediary and kind of callback which will be handling by asynchronous programming. Any question on this? The what we got from the first 1.1 version. Anyone? Background processor. It was from 1.1. Yeah. Thread and the other thing is APM. From 1.1 framework itself, we had synchronous programming available there. So this asynchronous programming model is a kind of callback. It's depend upon the callback. So once the process is done, then it will send a callback. Then you can know that task has been finished. Then in 2.0, .NET Framework 2.0, event-based asynchronous pattern were introduced. Along with that, yeah, thread was also there in the 1.1 itself. But thread was having like, it was having simple thread. But the problem at that point was you cannot, let's say you are having some task where you need to pass certain parameters. So that thing was not available in 1.1 framework, which was later reintroduced in the 2.0, and they have introduced this event-based asynchronous programming pattern and this parameterized thread. Then this background work is an example of event-based asynchronous programming pattern. So what event-based asynchronous programming pattern is like, you have certain tasks, make it async, and then there would be certain event which will be again calling that whenever the task got finished. And asynchronous programming model is this programming model is like, you have certain tasks, there would be begin request, end request. So based upon that, the process would be done. Then in 3.5, I think the task was introduced. Task is a like kind of wrapper of all of the things that was developed, and they might have rewritten the whole thing with this new programming model. And there is like there is a parallel library as well. Many of us might have used it. Yeah, for each. So that is a TPL. In actual terms, all are TPLs only, but that this is having the separate library, which is a parallel APIs, and then when we have a task APIs, and the data flow is one of the other item, which is like consuming the data. And if let's say we have two data over here and that need to be merged on, we will talk later on this topic. This is a very vast one. And the evolution is like we have thread, APM, that is asynchronous programming model, and event-based asynchronous pattern, and then we have task-based asynchronous pattern. Task-based is like the one we are using with the task. So we will look into these things uh, one by one. So let's start with the thread and thread pool. The basic This is the basic building blocks of asynchronous programming. Then we will look into the parameterized thread. So let's look into the example that I have done. Mainly, I have already created the whole the examples, but I will be creating a new one where I will be just copy pasting to have that single item in the place. Anyone have used thread for synchronous programming in older version or new version? Okay. Okay. So how was that used situation? Okay. So to make the UI responsive. So the best benefit we get from asynchronous programming is not the web responsive. It's responsive where where the application can take more requests. So your UI, whatever UI will be designing, that would be like taking the request and it won't hang. Like if you click multiple times, it won't hang at that moment, and it will start a background process through which you can have certain progress bar to show up. Any other benefit of asynchronous programming? Okay. So what if we have a single processor or maybe 8 or 10 cores there, and then we have done a parallel dot for each, which will have a kind of consuming the whole processor, and that task will eventually die. So that is what this things depicts. Like if we have lot of threads, and then of course our performance will get decreased because thread doesn't come as free, so that you can consume the whole resource. It won't hamper your application. If you have consumed the whole thing, then your machine is going to die. So this is like unhandled threads. It can happen something like this to machine. Debugging, they have released some techniques in Visual or process in the Visual Studio. Yeah. Right, you can do a flagging there also. Okay. So the first example that we are going to see is we have this long process where I will be making the thread sleep for a certain time, and then it will go for up to 30 loops. And the main thing, like the first example that we had given is like making the things responsive. So we have the console application which will accept the input as well as process our background task. This is pretty simple to understand. We have loops, and in that I'm making it sleep. Now I'm declaring the thread, and initializing this, if you see the thread parameter, it can accept the method directly, and then we are assigning a method into thread, then making it start. And now on we have another loop. This will start at this point, and then we are doing another loop where I'm just reading the user input. If it's T, then it will abort my other long process task, and it obviously it will break the current for loop. Yeah, this example doesn't make sense, like what is the necessary of doing like this, but just to give an example that things would be responsive, this dots are coming for the task which other long process, and then main process is having accepting lines. So if I click on this one, after 10 hits it will stop. So if, let's say, this is my responsive and then I click on T, so it will end up my thread. So this is one of the very basic example that what we can achieve with the thread. So in same way, if we have a long process, we can do something like this as well. Any confusion on this? We have, see, the main focus point is thread initialization, start, and then we have something abort there to make it. And one more thing, if you have certain a main task and then your background tasks are there, so if main task is going to be killed, then eventually the other child task or what nested task would be killed at that moment. So once the console application would be closed, the other threads would be closed as well. So that comes under the application domain. We have application domain, and there you have certain uh, allowed threads to run into it. Going back to the this parameterized thread that we came with the 2.0. One easy question is like why I'm explaining about threads and all that, because there's a basic part and we are not going to anyway use it. And the thing is like it would be better if we start from initial what came with the 1.1. At least we should know what are the things available there at that moment and what are the benefits that we are getting with the newer frameworks. In that way we can be more like know about the things what came as a new and what is the advantage that we are getting. So that is why I'm trying to cover up the basics, the previous uh, technologies also. So over here we have a simple class where I'm having the few properties over here, and that will act as a parameters for my thread. Like in the first one, we are not able to pass any parameters over here. And in this version, we have created a class thread parameter which will be passed as a parameter. Then so this is my main project, sorry, main function, main long function, which will process the stuff for me. And in this one, I am having this object as a parameter. You cannot have like a strongly typed directly there. So after making it object, you need to parse the values, and then you can process the things. Now to call it, there is something like thread.start would be anywhere there, but it will accept the parameters there. So what we have got is we have created a new object of thread parameter, and then we have something called parameterized thread start. So this is going to accept my method with this process request. So now I am explicitly telling that my thread that it will accept the parameters on this function. So after initializing that, we are going to call start like in previous, but over here we will be passing the parameter. And as a result, this function would called and typecast this value. They are not allowing it. Yeah. I mean, the starting of thread, it was designed like this only. Yes, task is strongly typed. You can get a result also. Okay, so this thing is doing what? Just getting the parameters, and out of that requested string will be coming, showing, and the number of counts, how much time it would be repeated. So we just have dots over here, and then after certain loop, then based upon the count, it will just eventually die the thread. So this is about thread and thread param. Let's move ahead with other APM. Anyone have used APM? No. So the APM pattern is there are function in the APM, like it's just a pattern, but you have to have some convention there that depends upon the async result, and there is the begin and end methods. So what happens is uh, you start the process with the begin method, whatever begin with the prefixes there. Then whenever the result you need to call the end method. So that is the way that APM works. And the callbacks, like whenever something is done, you need to process some item. Let's say on the UI you have long process that is done, now you need to display. So the callback happens with the help of async result. And EAP, which came with the 2.2, is having the kind of event-based functionality that is much simpler with the in comparison of APM. In that we will have uh, has anyone seen the WCF while creating the web reference? It creates something. with async. Mhm. Begin request. So that is what the EAP is there in that point. So that is there would be handling also that you can handle, and whenever the things will ready for your use, then you can have the callbacks there. I mean, whatever data would be returning, you can consume it. So that is by default provided by that the add web reference feature, and the background worker which came with the EAP. I'm not going to cover the background worker as I will be just showing up the what EAP is. To just display this thing, uh, is it visible? No. Oh, it's too light. Oh. Anyway, I will be showing with examples. Oh, I missed out some thing there. So we have a problem over here. If let's say we have long task, a list of long tasks, and what we are doing is we are creating a thread every time. So the thing is, we create hundred or thousand of threads based upon certain requirement, and that will end up my system with consuming the every bit of resource, and eventually this thing will be very slow and die also sometimes. So to resolve that, thread pool is there. Like even with the task and this every models, we have thread pool inbuilt into the .NET framework. So what uh, thread pool will do is, like if you have hundred of threads running there, so thread pool will handle the stuff like how many numbers of thread need to be created, and if it got increased, then it will queue up the things. So that is the advantage of thread pool. And if something is all something resource has been created, and then the same thread can be used for the second process. The actual process, what happens is with the threads is like we have multi-cores processor, and in that we have a single processor in which we have multi-cores, and there is something like caching mechanism also. There is a RAM like to store a temporary file, storage or whatever processing you are doing. So temporary things would be stored in that level. But when it comes to processor, it needs to have anyway everything need to have certain input and give output. So what processor does is it gets instruction, and with the registers and all that stuff, it gives certain output. And with the threads, what happens is if we have certain, let's say 2 3 cores, and we have initialized our thread, so it will go into the first core, let's say, and now second thread or something will go on to the second thread, and sorry, second processor core. So it will do split the task between the different cores. Now the thing is like these cores will be processing. Now we need to get the information from those cores. So the thing is like there is something caching there. Processor need instructions. So what the instruction will do is it will directly send it to the processor, and the processor will split the task and do the things. Let's say if core 1 has done the task and now it need to be merged on the core 2 layer. So the instruction which were put on the core 1 that need to be sent to the core 2. So on the core 2 the data will be there and then the whole thing will be consumed. So this is like having problems on the thread. So these things are like time consuming things. So we should not apply threads everywhere. Wherever it's essential we can use it. So these are things are like uh-huh. Probably you cannot say that it will run on the thread. Depends upon the processing. It generally it will go into the core 1 if you have synchronous way. The thing is, I think that is handled by the OS kernel. So OS kernel deals with that, and that is why in the new processor we have large number of caching L1, L2, L3 cache we have. So those caching keeps the information, whatever instruction came from the bus or memory, then it stores there and do the processing and sends it back. So this was the way to queue the task under thread pool. So by name itself, it's saying queue. So whatever task would be there, it will be queued up. And these things, thread pooling comes with APM, EAP, or whatever the new patterns we have. So they are having the consuming the thread pool. So it's advisable to go with this the APM or EAP or whatever the items there instead of depending upon thread until unless you are sure that you are handling it correctly. Otherwise thread would be most faster as there would be no overhead there. Pardon? Yeah. There are certain APIs which was built upon APM pattern. Like this one, we have the file stream as regular. I'm just for the information, I'm just reading certain file from the system directory. And this, if you see this thing, we have begin read. So async pattern will always start with the begin read, begin whatever the name would be. And to get the result, we have to use end result. And this will give you the async result. And this end read, if we go into the definition over here, so this will make more sense. So we have return type, whatever return type would be there. Then we have end read with the async result, which will get from the begin function. So it will stop over here whenever end request would be there. It will read at that point. Then then we will get the data as a whatever return type would be there. So this is just a simple example to converting and consuming the APM. But how to create it? I will show with the simple example. Let's remove this thing. So the focus point is begin read, end read, and end read will give you the async result. So this is a simple example which we will be creating a APM over here. Now with this encrypt decrypt function we have, and that need to be a synchronous way. So you got to create a delegate which will like request for certain task which will be having specification to have your long process in that place. So we have initialized this delegate with the my function called decrypt, which will just sleep for a certain time and then it will result something. So the delegate creation and then initialization of delegate with my function. And now as usual we have begin invoke. So once the begin invoke is done, we will have a function which is called async callback. So whenever this long this item. So async callback is whenever the long processing has been done, then to which function it will get called. So that means over here from here it will get called on the async call, this decrypt callback, which will accept the async result. It's always async as result. You cannot have something else there. So out of this one, you cannot pass the object in the task like we pass the object directly in the in the thread param that I have shown, that will is passing the parameter directly. But over here, it won't be having that thing. Instead, it will be having async result, which will have the object, and that again need to be passed, and then with the end invoke it will get the result for you. Yeah, there are three available, like whatever the input item would be, it again based upon the delegates as well, no? The delegates that we have created. So based upon that delegate, where you want to pass. This, yeah, Mark, this is a callback. Yeah, once the things has been completed. Okay, so if we run this thing, I'm sleeping it for a certain time because this task will just run and vanish there. So I'm making it sleep for a certain time. So it's same process we are doing. Yes, sure. Uh-huh. Number of function, you got to split them up. Or if let's say you have certain tasks, you can have another function, and there you can have all other three dependent function. Mm-hmm. You can have multiple APM process for them. Let's say you have 2-3 function there, so you can split those things with the this pattern end and the begin one. No, he want to have multiple function.
Chaining kind of thing also in delegate possible. If you delegate, you can call that.
Yeah, based upon the callback, you can chain those things up. But to do that, you will be ending up with lot of codes in the APM. Moving on to EAP. EAP is event-based asynchronous. This I'm consuming the web client API. There we have already a completed event, and then we can you can move this thing to the bottom. So now we have something download string async, and the general guideline with the asynchronous programming is with the async keyword. With even if we go into the 4.5 also, you got to use the async keyword. It's a guideline. You can do anything, but it's a guideline. So what is happening is they have created their own system, and then we are requesting for certain URL, and then after complete it will get called to this function, which is this only, and then this is customized one, so you are getting this event arguments. So the whole thing, like I have shown you with the APM, this can be also customized according to your need.
Normally it accepts event ARGs, so you can override that.
Pardon?
Normally those events accept event ARGs.
Yeah.
So we can override with our.
Yes, right. So the processing is happening. Mm-hmm. Yeah, it will show over here. Oh, okay. That's so stupid. Oh, I am not having that dots. So I'm getting the result, and this thing that I've shown you will come with the add web reference. So these things will be pre-built there.
If the person is providing the API, they never write this assessment. Itself. It runs with the
Already web client has written.
They have just created a new proxy class method there. So whenever you create a proxy, it will by default create it.
I've seen this. I will like simple method also.
Uh-huh.
And if I expose that,
Yeah.
normally it comes with an S version of that.
Yeah, it will automatically create. Means that is the feature of .NET or Visual Studio, you can say. No, no, no. You can have your web service by yourself only, and then if you import it, those things will get there. So that will handle this network latency thing. So we are running short on time. So we got this begin read, end read, and in EAP we have got this event handling mechanism. Now moving into task. How many of us used task till now? So around more than 50-60%. So I will try to give you some new things that is in the task and the basic stuff also. Anyone can explain the what is task? And till now we have seen this histories of asynchronous programming. So what is the thing we get from the task?
It is kind of smaller unit of work which are assembled together. So packages in the task. And that simultaneous will do small unit.
That you are saying about relationship, like we have a certain task and then we will divide with some more tasks, right?
Yeah.
So it would be kind of creating list of the task and then consuming it. The main thing is it's pretty simple to use instead of going with the thread and all those APM. You have seen this, how much code that we have written to do a simple thing. And the thread one was very simple to use. But the thing is that thread pooling and handling the things, it's pretty difficult in simple thread. So that is why the task is there, and it's much simpler to use. And to create a task, you can attach any function to the task, and that will handle it asynchronously. So to create the task, we have this start function. You create a task, then assign some function to it, and then you can start it right away. Then we have start factory dot start new and task.run. All things are will create the task, but with the parameters, it has different. You can put some more parameters in those uh, functions. So this is task.run came with the 4.5 or 4.5. So in that you don't need to pass any parameter. It will just, for simple use, you just task.run and done. And we will look into the from async and the cancellation of tasks and exception handling. So this is pretty simple function with synchronous call, where I'm getting the web request like in the previous example, but it's just a synchronous version of it. So we will consume it with the task. I need URL request. So we are passing the URL request. As usual, it will take certain time and hang our main application and get the result. Okay. Now I'm trying to wrap this thing to with the task. If I am migrating, is it having problem? Is in understanding. Okay. Now this is just another function where I am just using task factory dot start new, and in that I am calling this download web page synchronously. So we have synchronous version of certain task, and then we are consuming just with the task. Now what I'm trying to do is I'm creating a download task by calling this function. As usual, it will have wrapped the function into the task, and then we got the task, and then what we will do is we will check its property having is completed. There are certain properties with the task we can look into later. So we will look is completed, and we will loop based on once it's done, then we will show the result. So it will make my application responsive. So after a certain time we got the result.
This is also useful when one task is dependent on another one. You can use that is completed to check if the task A is completed, then use the result of task A and task.
No, yeah, that can be used, but there are certain built-in functions that can be used directly, which I'll be showing you.
The benefit of getting this meeting, like
Not
get that it's a normal synchronous,
Uh-huh.
you have to not get it.
Yeah, that to make it responsive.
Responsive,
Yes,
you get what is going on
right.
in the task.
User can know something is going on instead of something got hanged. Now, if you look into the this process, what we are getting is we are making obviously URL and then waiting for the response, and this from response we are getting the streams, and then from the stream we are getting read to end. So if we see look into this label, request will anyway not take time, only the end will take time. So for that what we are doing is we are keeping the whole thing as synchronous version, and our main problem is happening on this read to end. So we will try to optimize this thing and see how we can use it. As on this one we have something from async. So if there are certain things which certain APIs which are already having this APM or EAP or whatever things are there, and if they are exposing, we can wrap those things up in the task and we can consume it and show it to user. So in this level we have already iAsync result. So again this example from APM, we have begin get response, and then what we are doing is this will get a synchronous result, and then we have something called from async. Whatever the asynchronous task version would be coming, you can consume that thing and do the processing on this level. So it won't be happening like it will wait for something. As some things are pre-built, then we are just consuming it with the task to make it faster, efficient. And these things can be used with the web APIs also. When we have HTTP response there, web API has inbuilt feature which can consume this from async.
Suppose you are requesting to a particular URL, right?
Uh-huh.
Suppose that URL is expressing some async method, like download async.
Okay.
So in that case also we have to wait for time to get those things. So we can directly manage inside task to perform it.
You can do in this way also.
But anyways, the task needs to wait for that URL to get executed.
But that URL we are consuming this thing now. We have this synchronous version where we are passing this parameter and creating a new object there. and then we are reading the things. So it's kind of chaining up only. Like you have something, you are just consuming it to make wrap the things into the task. See, this was the problem. What you are saying is we are making a URL request, right? And from there we are supposed to get the result. Then wrap those things into the task. That is what you are saying.
Yes.
So this was the previous example only. We had done in same way, but we have seen this by analyzing the code. It will mainly wait for this level.
Yes.
So if we have something inbuilt, we can consume those things from async.
But it doesn't have any async method and directly you have to use like
Yeah.
yeah.
Yes. So this is what I'm just showing. This feature is also available if you want to enhance something, and if the API is already providing some asynchronous pattern there. So this is one of the example, and it will be the result would be same. And the other thing that we are getting is now with 4.5 we it came with the async await keywords. So the same above example where we were consuming the APM version of API, over here we are consuming just async await async.
This is simple.
Yeah, obviously.
I was looking for this.
You were basically asking for this only.
Yeah.
So this will make it more simpler there, and this itself, if is it visible? Task string. So that will directly give the task base. Okay, but we won't be covering async await in this is. I'm just showing you that there are three ways how you can improve it something. Okay, how many of us use cancellation of the task? None of us. Okay, let me try to describe it thoroughly. Mhm. There are certain things like we never cancel it. In same way, you are obviously supposing that this need to be run throughout means the entire kind of service, and in that way we don't need exceptions also. Isn't it? Who will handle the exception if it came with the task? We will look into that.
This last example,
Uh-huh.
is it going to affect the actual execution time? Not
Yes.
the receiving time, like get the result right away.
With asynchronous version it will be more efficient, and obviously it will increase means enhance the time also if you have certain long things running there, then only. Otherwise even the synchronous version will run
Even that
faster.
chaining, not in async of it, I'm not sure how it
Hmm.
is working. But in the chaining one, because of that thing we are already doing. Since we are writing those code, because of that it will.
Yeah. Okay, the cancellation one, let me remove all this example. This is clear, right? We are running out of time. I'm showing you from that example itself. I'm consuming both progress and cancellation. For progress, we have a simple class called import progress. On this example, we will try to read the XML file and show some information. So in this level, we have import progress, and there we have just simple properties, which will, the thing is like how to consume progress is, you have your class ready, and then on the task level or wherever you are doing the long processing, there itself you have to populate these values. Clear? And this is just another interface which will be defining some methods over here, which will be accepting the cancellation token. Okay, this cancellation thing can be happen with the cancel. There is a pre-built cancellation token which can be used to cancel the task. So in this one, this we have function overriding where we have the directory cancellation token and iProgress. The thing is, this version, this feature came with the 4.0 with iProgress, and this is just an interface which will get changed on the calling of consuming of these items. So we have defined our interface, and this interface is going to be implemented on my data import. So if you see the see the functions on this one, we have the multiple version of same method. So we have multiple item there, which if there is no cancellation token assigned, we can use cancellation token dot none there. And if something is having the cancellation token, we pass, and if there would be progress, then we can call this new progress. This two things comes with the system namespace only, system.progress. The basic principle of the progress that I have told you, you have to just modify the modify the object on the task level in under long running process. And now whenever you need to show the information to the UI, then you have to use the report one. Yeah, report comes with the iProgress only. So the thing is, we have progress observer, and there we are using report. So whomever has subscribed to this iProgress, they will get the information about what has been changed. Clear? Okay. If we look into cancellation token, yeah, sure.
This is about what we change, how much is
Which one?
this line progress?
It depends upon you. That event has,
Sending 5 leads.
yeah, I'm calculating the things. I'm sending, creating a new object there. So this object, I'm calculating the things and creating a new one. Yeah, report, obviously you need to show some progress. So if we look into the CT, that is cancellation token, we can get is cancellation request. So from this property, we can know whether user has cancelled or not cancelled. Okay. So this property comes with the cancellation token directly, but there is some other function which is throw if cancellation request. What will happen is, to check the cancellation token, you have to always check whether it's cancelled or not, and then based upon that you have to end up your task smoothly. But with this throw if cancellation request, it will check automatically and create an exception whenever task got cancelled. So it will just reduce the if else condition there. Fine.
How this cancellation is triggered? How the user is going to cancel?
That is I will be showing you. This is just a basic structure, like what are the things happening under core area. How to trigger it can be triggered obviously from outside. So see, if this function we have created object of it, obviously we will be passing the cancellation token to this function, and if we from outside of this function, if I cancel it, it will get affected over here as well. So now if we see this one, we have throw if cancellation request. Forget about other stuff, mutex and other things. So is there everybody clear with the cancellation and the progress up to till now? Any doubts? Okay. So how to call it? Now what we are doing is we are creating an object of my data import to consume our means to consume this. What is? Sorry. Which will be accepting my directory and other stuff to do the whole thing. So main thing is directory, and then it will loop into it, and then it will process my XML files. So on this level we are creating a new function data import, and we have I import there. Okay. For the time, let's leave this one and focus on this item. We are creating a cancellation token source, and then the cancellation is like you put the token, and based upon the token it will work. So the main thing is this cancellation token source, then assigning the cancellation token, and then we are going to pass to the function. Now we have the CT in place and display progress, which is like subscriber that I have told you. The image progress that we had modified there, that would get subscribed on this function. So on this level we can update our UI. Now on this thing we will just like previous, we will look for is completed, and based upon that we will be showing the user. Now we are processing the things at same time we are accepting the user's input. So if user input is Q, then we will cancel our whole task. So we got this 3 XML processing there. The display is happening on this level. Cancellation, oh, I haven't shown cancellation. Now if processing is happening, it's way too fast. Let me slow it down. Yeah. Let's do one. So I pressed Q, and as a result, the task got cancelled. So what is the advantage that we got with the cancel? Uh, the first advantage, obviously, user can cancel it. And the second thing is, if something got cancelled, then we can release our resources which were getting consumed. So in this level, we don't have to go to the mutex and all that. We will look into later part. What this thing is doing, this is taking the the file which are getting processed. It's taking the authority to handle that file with the mutex, and it's saying no one can touch except me. So if these things are there, so on the cancellation or throw, when exception occurred, you need to release those resources. So that you can do with this cancellation. Yeah, how to, the main thing has been left out. Now we have task there in place. So how to attach the cancellation? We have seen the token source, and from token source we are creating a cancellation token, and from the cancellation token we need to attach with task, right? Otherwise how that cancellation would be happening. So we have got the task.run, and after that we have to pass the cancellation token. That's it. So to summarize it, we have I progress bar which can be consumed on the long running task, and then the to have a cancellation token in place, we need to create a cancellation with the cancellation token source, and then that need to be passed into the long running process. And this long running process, what it will do is it will create a task, and then we have another parameter where we will be passing the cancellation token. So now everything is in place. If we cancel it, it will get called over here, and the checks can be done on this level. So it will give an exception, and that can be handled on this level. Clear? So the last thing is task error handling. Whenever task runs and in that exception gets occurred, you will always get the aggregate exception. The aggregate exception is like container of all those exceptions which occurs into the task. So there are certain features from aggregate function which can be consumed to show or log the errors. There are certain things like we can have a running task, and then we won't be handling exception at all. In some of the cases, like if we have certain services and you are caching something, and in that we can just left it out without handling the exception at all. So in this level, we have task there, created the object of task, and if we look into the wait one, it shows the aggregate exception, means it can throw the aggregate exception. Now, if it throws the aggregate exception, the features that we get from aggregate exception is flatten. So if let's say we have, obviously aggregate, as I have told, aggregative exception is a container of certain errors there. So flatten will be flattening all this exception occurred under is available under aggregate exception. So now after flattening, you can check the actual exception happened. And then we have something handle. This is again coming from aggregate exception itself. So handle is, if let's say you want to handle certain exception by having something on common place instead of writing it everywhere. So handle accept the predicate which can which you can put as a value there, I mean function there. So this would be in the single place, and then we will just calling this everywhere. Okay, so the key point is we have flatten and handle to handle the task exception. There are certain situations you don't want to handle any stuff. So this comes with something unobserved task exception, which accept the delegate function, which will have unobserved task exception event arguments, and there you can get all those exception, and the key area is set observed. So if something exception gets occurred, and this is particularly for task only, kind of global exception handling for the task. So set observed means this says that exception got handled, and it won't throw the errors. In same way, there is already a setting available directly under app config. So in this level, there is attribute element called throw unobserved task exception, which you can make it true and false, and it would be applied globally to the application. So if something is there, then if you run this application and have this one or this app config, then it won't throw any exception. It will just end up like that. But the other thing is, if you have something chaining of task or relationship under the task, then you can get is faulted there. So from that you can know whether the task has been cancelled or some problem got occurred into that task, and you can handle based upon that also. So we have flatten method there. We can get the inner exception from the flatten method, and then we have handle method to handle certain exceptions. And this is kind of global setting that we can do. Okay, to summarize both of them, we have cancellation token source. Out of this, cancellation token would be generated, and that can be handled with the throw if cancel request. And from async, this is the keyword that if something is asynchronous there. And progress bar, same as I have explained. You can just go through this slide and get the idea about what is the main core things are there. Then task relationship. There can be a two kind of task: relationship with the child one and the chaining of tasks. So if let's say like you were giving an example like 4 5 are there, then that need to be done one by one, and it will, the second task will take inputs from the first task. So these things are kind of chain tasks. And relationship is like you have one task and you can attach more tasks under that one. And there is nested task as well. Um, okay, we have continue when, have you seen continue option in the task level? Continue with any and all. So that, uh-huh.
When all
Yeah, but when all is a different thing. When all would be done, then only. Continue with is for chaining up the task. So if we need a chaining of tasks, we can have this continue with whatever items would be there. And as a parameter, we have something task continuation option that we will be looking. In the task creation option, we have attached to parent and denied child attached. That, let me give an example on this points. The first thing is pretty simple. We create a task, and under that we create another task. So that would called a nested task. And then if we have something like um, parent-child kind of task, then we can do, see in the start new, we have another parameter task creation option, and then this is having attached to parent. There are a couple of other items like attached to parent would be there to create a child task, and denied child attached is like task dot run happens. Means it always takes as deny attached to task. So that will act as a kind of nested task only. And there are other attributes which will uh, make the task more, you can say that long running. Let's say example on long running, you are saying that this would be the long running task, and the processor or the framework can focus more on that one to optimize it. So these are the few things which we can do with the attachment of task and with the continue with. Okay, so on this one we are creating the URL and getting the response. So after getting the response, we want to continue with something other. Okay, so this task itself is having the continue with, like all have said we have continue with option there. So we can have continue with, and out of this one, this is my web, if we can see over here, web response at TD, and we can consume this thing to uh, have another process. So this chaining of tasks can be done with the continue with, and the parent relationship, child parent relationship can be done with this attached to parent. So these are two things from the task relationship. Okay, that is all. Any questions? It should be. Uh-huh. Yeah, very nice question. Ask is having I disposable. So whether to dispose a task or not. Any opinions?
I think maintenance will be completed.
Huh?
Maintenance is good.
Many times?
I think garbage collector.
Okay.
Garbage will
Yeah, garbage collector will be there. Any other thought on this? So most of us say that garbage collected.
It does for everything.
That's cool. Okay, yeah, that would be garbage collected most of the time, but there are certain times that need to be handled. Like in this one, we have weight handle there. So at that moment, if we are consuming something which cannot be disposed by itself, or if you want to increase efficiency, but that doesn't mean you dispose it everywhere. If you see a real problem in the application, try to profile it, then based upon that you dispose correctly. And it's not mandatory at all to dispose every time. Any other doubts? I guess no. Okay, we will end this session now and try to give feedback, because I will be continuing the other two sessions also. So according to that feedback, I will modify or improve certain things. Thank you all.
Thank you.